Hello friends, in this video we are going to discuss about liquid crystal and its classification, nematics and cholesterics. Myself, I am Anusri Anil, final year MSc at Physics student of Regional Institute of Education, Mysore. We are going to have a general idea about liquid crystal and we will discuss certain properties of nematics and cholesterics. The word liquid crystal consists of two parts, liquid and crystal. Liquid means it's in the form of a fluid and crystal means it has a certain characteristics such as sharp melting point, sharp boiling point, structure, layer structure, etc. Consider heating of a solid. We all know that when we heat a solid, it gets converted into a liquid. In 1888, an Austrian botanist, when he heated a particular chemical during his course of experiment, accidentally found that the chemical is entering to a new state which is intermediate in between solid and liquid, and hence the picture of liquid crystal came into the world. He also found that the whole process is reversible. In solids, when we are talking about solid here, we are talking about crystalline solid and not taking amorphous solid into consideration because we are going to focus on liquid crystals. In solids, the molecules will have good orientation and will be well aligned. If the temperature is increased, the molecule acquires the energy from heat energy and the order gets distorted and hence liquid crystal is formed. On further increasing, we get liquid state. Another important feature which we should focus while discussing liquid crystal is opacity. Opacity means the ability to see through. We all know that solid has the least opacity and liquid has the highest. Liquid crystal has an opacity in between that of solids and liquid. In liquid crystal state, the molecules can move about and therefore lack position order. However, the molecules strongly interact and are arranged and oriented in a crystal-like way. Thus, they possess long-range orientational order. Liquid crystals can further be classified into three types: nematic liquid crystals, cholesteric liquid crystals, and sematic liquid crystals. The figure here shows the diagrammatic representation of each of these types. And in this video, we will be discussing about nematic liquid crystals and cholesteric liquid crystals. Now let us discuss the first type of classification of liquid crystals, that is nematics. The word nematics means thread-like in Greek. The molecules as shown in figure are elongated rod-like in shape. The molecules will be suspended in a disordered manner with all having same orientational, that is vertical, and pointing along the same direction. When I say it is disordered, it doesn't mean that the molecules are not aligned at all. It means that in nematic liquid crystal phase, we cannot predict where the next molecule will be. We can picturize these molecules like some threads which are suspended or hanging from a common ceiling, like as shown in figure D. There is no positional order but has orientational order. As I have said earlier, the molecules in nematic liquid crystal phase are disordered or distorted. That is, the position of the next molecule is not well defined. Hence, there is no degree of order and no layered structure as we see in crystals. There is some order in the direction of the molecules, and these direction of the molecule tend to be parallel to some common axis which is labeled by a unit vector called director, which is shown as n cap in the previous image. Nematic liquid crystals can flow like normal liquids, but it has very low viscosity. While writing difference between nematic, cholesteric and sematic, we can consider these points, and they are formed at relatively very high temperature. They can be aligned by using an electric or magnetic field. Nematic liquid crystals can be further divided into biaxial nematic phase, wherein the building blocks are shaped in form of long rectangles, and the next one is exotic nematic phase, which has higher symmetries such as hexagonal, cubic and icosahedral symmetry. Two examples for nematic liquid crystals are para-azoxyanisole and MMBA, which is N-para-methoxybenzylidene para-butyl aniline. The structure of these two compounds are as shown. And another important point to be kept in mind is nematic phases occurs only with materials that do not distinguish between right and left. Either each constituent molecule must be identical to its mirror image, that is, it should be achiral, or if it's not the case, the system must be a racemic mixture of right-handed and left-handed species. Now let us move on to the next classification of liquid crystal, that is cholesteric liquid crystal. This phase is composed of nematic mesogenic molecules containing a chiral center which produces intermolecular forces that favor alignment between molecules at a slight angle tilted to one another. This was found in pure cholesterol esters and hence the name was given as cholesteric liquid crystal. If we dissolve a nematic liquid, a molecule that is chiral, that is different from its mirror image, we find that the structure undergoes a helical distortion. And the same distortion was found in the cholesterol derivatives. In this liquid crystal, long range orientation order is found and there is no positional order. Another important point to be kept in mind is that cholesterol itself may not be a cholesteric liquid crystal or it may not show liquid crystal property, but the derivatives are showing liquid crystal properties. This fascinating categorization from liquid crystal family is largely due to its unique optical property which is imparted by the helical structure. And the necessary condition which is required for the formation of cholesteric mesophase is chirality. In this case, the director changes or it varies in direction in a regular way. The structure might be similar to nematic, but each plane of the molecule is actually twisted, likely with respect to the above plane and the plane above it. When we move along a direction normal to the plane, the director rotates continuously, hence giving rise to the helical structure. The structure is similar to nematic phase and hence called as chiral nematics. Each layer in cholesteric liquid crystal is tilted with respect to each other and hence the molecule will take one complete turn of 360 degrees to make it helix. It is something similar to RNA and DNA structure. And cholesteric liquid crystal tends to change its color when the temperature is increased. This is due to the fact that pitch is inversely proportional to the temperature. So this is a schematic representation of cholesteric liquid crystal and the arrow mark here in the first A figure shows the direction of the molecules in each plane. When the molecule completes a full turn, that is 360 degree, we say it is pitch length. When we increase the temperature, the molecule of each layer acquires the heat energy and hence it can rotate to larger angles and the molecule reaches back to the starting same direction faster than the first case, which is of lower temperature. This reduces the pitch length. The pitch length is generally of several thousand angstrom, which is comparable with the wavelength of visible light. The left side image shows the case of lower temperature and the right side shows the higher temperature. The pitch length is also affected by pressure, electric and magnetic field. As I said, the pitch length is of several thousand angstrom, comparable with wavelength of visible light. This gives the cholesteric liquid crystal the ability to selectively reflect the light of wavelength which is equal to the pitch length. And when it is comparable to that of visible light, we see certain colors getting reflected from the cholesteric liquid crystal. And this feature has enabled us to make use of cholesteric crystal in a number of ways, especially in medical field. We see MRI scans of brain which has certain color in it, and these colors are due to the cholesteric liquid crystal used. They are also used in study of skin cancer. The carcinogenic area has higher temperature, and as the temperature varies, we have learned that the pitch length varies. Hence the reflected color also varies. This feature has enabled us to make use of cholesteric crystal to the medical field. And one example for cholesteric liquid crystal is cholesterol benzoate. The figure, the structure and the real life figure is shown in the slide as follows. So that was all about liquid crystal and the first two classification of liquid crystal, that is nematic liquid crystal and cholesteric liquid crystal and their properties. Hope you guys have understood, and thank you.